Hey everybody, this is Miss Eisencraft with another solving by elimination tutorial video. Okay, sometimes when you're trying to solve by elimination, you'll notice it's kind of ready to be eliminated, but not really. Meaning the x's and y's are on one side of the equation. It looks like it's lining up nice. But if you added it, none of the variables would eliminate. That's because we need them to be opposites. So what you're going to have to do is you're going to have to do a little bit of manipulating one of the equations. So what I first of all look for is I look and see if either my x term or y terms are opposite in sign. See how this y is a negative and this y is a positive? I'm going to work with these right here and see if I could, since one's negative, one's positive, could I change one of these equations so that they are exact opposites? So could I easily change 5 to a 15 by multiplying it by something? Yes, if I made this a positive 15y, it would then be opposite of this and cancel out. Well, you can manipulate an equation. You can multiply it by 3 as long as you multiply the entire equation by 3. So if we do that, we'll have an equivalent equation, which then will combine with this top one. So I had to look at one of my terms. I chose the y term, and I decided, hey, if I make this number a 15y, it will cancel out. But I can't just make it a 15y. I have to choose whatever action I'm going to do to make this a 15y and apply it across the entire equation. So what can you multiply 5y to make 15? You need to multiply it by a 3. So what I'm going to do is I'm going to multiply this entire equation by a 3. Okay. Now this can get a little messy, so to make it really organized, the top equation, I did not change at all. So I'm going to write it over here. Negative 4x minus 15y equals negative 17. The bottom equation, I'm tripling. So I get negative 3x plus 15y equals negative 39. What I really cared about is that these two are opposites. So now it'll be ready to eliminate, we'll be ready to eliminate one of our variables. When we add it up, okay, always make sure one of your variables is ready to zero out. This is good to go. We are adding negative 4x and negative 3x, which makes a negative 7x equals negative 17 plus negative 39, yuck, negative 56. Okay, we are prepared to just solve for x now. Divide both sides by negative 7. X equals positive 8. Okay, so it looks like I'm going to go over here. X was 8. Okay, now, once you get X, I need to figure out what Y is. And I actually now have 3 equations to choose from. I could choose to plug in 8 into this top equation, the bottom equation before I multiplied it by 3, or this third equation. I'm just going to choose the top equation. And in place of X, I'm going to put 8 because I just found that X was 8. Okay, and then I'm going to work it out. So this turns out to be negative 32 minus 15y equals negative 17. A lot of negatives in this problem. Okay to use a calculator. If you have negative 17 and you add a positive 32, you land at positive 15. Divide by negative 15, you get y equals negative 1. So there is your y value. Boop. Okay. Now to verify, I could plug those both into the equations, but I'm going to verify by graphing, my favorite method. Okay, I've already typed them in. I have negative 4x minus 15y equals negative 17. And the original equation, negative x plus 5y equals 13. And I notice the solution is 8, negative 1. I also wanted to show you that after I tripled this equation, if I click over here, it'll take this equation away. I tripled this equation, right? It made the exact same equation. It's equivalent. It just is another way of writing it. And so that way of writing it allowed us to algebraically eliminate the y term. Just wanted to show you here that it doesn't matter which one I typed in. It's the same exact line, and it's still going to intersect at 8, negative 1. All right, hope that helps.